Hey guys, this is Ronzero Studios here. Today we'll be looking at DFS, or Depth First Search. DFS allows us to go from a start node, such as this X node, and then go to all reachable nodes from that source. So if we start with this X node, we'll be able to reach this node, and this node in the graph. But we will not be able to reach this node because it's not reachable from the source. The DFS graph traversal algorithm acts as a maze almost, solving a maze. So if you go to the maze analogy on the right, and we start from this X point, and maybe you want to reach this X point at the end, the red one, we'll go forward, right, because it's the only way we can go. But then we're met with the decision, can we go down or right? Say if we go right, we'll go to this point here. But then it's a dead end, there is no way to go. So then we'll go back, looking for any other paths we haven't gone for yet. So there's the down option, we'll go down, and then we're met with another decision. Say we go left, there's another dead end, so we'll go back, and we haven't gone right yet, so we'll go right. And we can go down, we'll go right, met with another decision, say we go right, there's a dead end. And in this way we go through all possibilities, and then we go to the X at the very end. Here is the source code for DFS. As you can see, DFS is a recursive algorithm, meaning you're going to have to run the function many times over and over again. There's an extra variable that I might have not told you about, and it's this one here. It's the visited array. This will let us know which nodes we have visited or haven't visited yet, and it's quite necessary, although it isn't exactly completely necessary for pure DFS, which is a version that doesn't use this. However, if we don't use this, we can end up in an infinite loop going through the same few nodes forever. If you go to the graph example at the bottom right, if we start here, we'll go forward, then we'll go here, but then we'll end up in an infinite loop for this section here, and we'll never go back to the start, so we'll never ever finish the algorithm. So the way this works is that it goes for each node's neighbors, all the different arrows going to all the other nodes from that other node. So all the different things it's connected to, and for each of them, if that node hasn't been visited yet, it will recurse to that node. And it'll keep doing this until the function for the very first node, the source node, is finished. Some people might be confused as to how this works in the terms of the backtracking. How does this backtrack? So say we have three nodes here, A, B, and C, and they're connected as such, and we start with A. If we follow the function as so, we will mark A as true, and it will go through all of its neighbors. Say its first neighbor is B. We'll go to B. And once we go to B, we have to recurse to B. Recurse to I, and I is B. When we do this, time essentially stops for A. So A doesn't continue until B is finished. So for B, we mark visited B for true, and it will go through all its neighbors, which it has none. And only when B is finished, we'll go backtracking back to A. And then A continues. So we're essentially backtracking because B halts A until B is finished. And then we'll go back to A, and we'll go to C. When C is finished, we'll go back to A. And then the loop for A, the source node is finished, so we're complete. That's DFS completed for this particular graph. Now let's see this in action in my website for the simulation.
Alright, so we're in the DFS article with the simulation in it. You can go check this out yourself at rodryan.github.io/algorithm. Need to include the /algorithm for now. I will include a redirect later. This article here has all the details we covered in the video, and later on, maybe later today, I'll be adding some extra features such as how the time complexity works for DFS. If we scroll to the very bottom, we can see the details of the simulation and how to use it. It's been written in Godot. Here's the pre-generated graph. You can drag anywhere to move around, and you can drag on the node itself to move the nodes around. Here is a toggle to enable pure DFS and a speed slider. You can double click anywhere to create nodes, and you can right click on those nodes to create edges. And if you're stuck making an edge and you don't want to make this edge, you can click escape. Say we want to start with this node. This is a fairly simple graph, just to show how things work. I'll speed it up a tiny bit. I'll make it pretty fast here, and we can just quickly take a glimpse of what happens in the simulation. As you can see, this node depth first searched here and all the way around until this node was already visited, so it'd go back, all the way back to the beginning to the source. I'm going to quickly draw a better example to show the backtracking, and I'll be making a quick tree graph. Alright guys, so I've included the tree graph, and I've added this extra node for an example I'll be showing a bit later. So this tree graph will help explain how the backtracking nodes. Say this node is node A from earlier. So if we start here, we'll go from this node, then we'll go left, we'll hit this node, then we'll go forward again, we'll go to this node, we'll go to this node, hit this node, we'll see this node's already been hit, so we go back, and we'll keep going back until we find a path that we haven't tried yet, which is this way. So we go this way, but it's already gone, so we go all the way back, we hit this node, we go for this, dead end, so we backtrack, and we try the other path we haven't tried yet, and we go here, and we've depth first search there. Now, if we enable pure DFS, however, and we set the speed to a bit faster, we'll end up looping between these 4 nodes here, because it'll go here, 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 and here. Let's see this in action. As you can see, it's flashing, which is really strange. It's not supposed to do that. That's because this has already been checked and it's flashing. There is no visited array, so there's no record of what's been visited or not, so we just end up looping through this section depth first over and over again for all of eternity. I can speed this up and you can see, again, that's just going to continue happening. There are some errors currently, so if I do add an edge while the simulation is running, it will break and the code wouldn't work. This code and this entire article, this entire website even, is completely open source, and you can edit it and make pull requests on GitHub by clicking the cat icon here. I'll really appreciate some changes, and I think it will be very useful. Thank you guys for watching. I'll definitely be making more tutorials in the future. Bye!